All right, here we go. Things to note with these problems. You need to show me your work, okay? If you don't show your work, I can't tell where you made a mistake, and I have to take all of the points away, and that's rotten. Algebra has steps, so many steps with algebra. Show me what your steps are so that if you do everything right except for that very first step, I can give you all of the points except for that very first point, okay? Show me your work. Second, do it in columns. Work vertically, okay? When you're jumping all over the place with your stuff, I don't know where to go next. So put it in a column. Here's the first thing I did, then this, just work your way down, okay? And then just write down the equation to start with so that if there's something wrong, like if you have questions on things, we can see where you went wrong, right? Maybe you just wrote the initial equation wrong. So write it down, show me your work. All right, these first ones are very basic. We are just literally solving equations, and this is a one-stepper. How do you solve that?
You subtract 5 from negative 11.
You subtract 5 from both sides. Remember, whatever you do to one side, you got to do to the other. This is 0, so x equals negative 16. Okay? You should all be very familiar with that. What do you do with this? 24b equals 50. You divide, right? You're always doing the inverse operation. You're doing the opposite of what you see. So this is multiplication. You divide it. So we're going to divide by 24 and divide by 24. Here's the deal. Your answer should be the reduced fraction, okay? A lot of times with these, it comes out to a number that has no end. We don't want you to round. We want the exact answer. So just leave it as the ratio reduced, okay? 50 over 24. Both of those are divisible by 2. So if you divide by 2, you get, it's my turn. You get 25 over 12, and that's as low as you can go with it. Just leave it as that, okay? Reduce your fractions and leave it be. Good with that? That's definitely the basic, right? It's about as basic as they come. Okay, we're gonna add a few more pieces in. Let's say we have, sorry, that's C, not B. We already did B. Negative 27 plus 6y equals 3 times y minus 3. All right, so we're just solving for y. You are going to distribute first. So that's negative 27 plus 6y equals 3y minus 9. What would you do next?
You have to isolate the variable.
You got to isolate the variable. So we got to get your variable on one side of the equal sign, right? I would take the 3y away. That's not your only option. It's just the way that I would do it. You could do it, take the 6y away. So you end up with negative 27 plus 3y equals a negative 9. Please don't forget about that negative there, okay? It's a minus acting as a negative, plus a negative, okay? Then you're going to add the 27. So you get 3y equals negative 9 plus 27. 18, good, yes, you're right. And then you divide by 3. So y is 6. Okay? I just said work vertically. Like, I need to see you're organized. You'll be fine. Okay. Last one of these. 3 times 2x minus 1 minus 2 times 3x plus 4 equals 11x. What do you do first?
Distribute.
You're going to distribute, okay? Note that your 2 is minus 2, right? So don't forget that. When we distribute our 3 here, we get 6x minus 3. What do I get here? Negative 6x or minus 6x. And then what? Minus 8, right? Or plus a negative 8 you could do. I always just make it a minus 8. So just be careful with negatives. I feel like that's where a lot of the mistakes get made. All right, so this is our setup. Oh yeah, sorry, we're good. Okay, so next step. Combine like terms, right? So we have 6x minus 6x, which is 0. Okay, so you don't need to write the 0 down. That's just gone. Negative 3 minus 8 is a negative 11 equal to 11x. Divide by that 11, and you get x is negative 1. Isn't it so satisfying to solve that? Oh, I love it. So satisfying. Sometimes, not always. Sometimes it's just frustrating, right?
That just, it makes it just so much better.
All right. Special cases. There are going to be situations where you will have different answers, not just x equals something or y equals something, okay? Here are your special cases. If something is always true, we call that an identity. That'll be something like 7 equals 7 or negative 1 equals negative 1. So notice there is no variable. It's not x equals 7, it's 7 equals 7. That's called an identity. Your answer means it's always true, okay? Sometimes it will never be true. When it's never true, we say that is no solution. And that's when you have something like 9 equals 4 or 0 equals 6, right? Those are not actually equal. If they don't come out equal, you say no solution, okay? Sometimes you'll have some that are sometimes true, and those are the ones you're used to. That's when you have one solution. So that's when your variable sticks around, like x equals 6 or x equals negative 2, or what if x equals a value that is sometimes true, okay? Okay, so let's try a couple of those. Let's say we have 11 plus 3x minus 7 equals 6x plus 5 minus 3x. Okay, so we're going to start by combining like terms. So on your left side, your like terms are your 11 and your negative 7, right? So we're just going to simplify that. 11 minus 7 is 4 plus 3x. On your right side, it's your x's that are your like terms. So 6x minus 3x would be 3x plus 5. Okay, now move your x over. Take away a 3x, take away a 3x. Those are both 0. So you end up with 4 equals 5. What is your answer? No solution. Okay, that is never true. Is my pacing okay right now? Too fast, too slow? You okay? All right, 6x plus 5 minus 2x equals 4 plus 4x plus 1. same thing, simplify. Okay, so we're gonna do 6x minus 2x is 4x plus 5. 4 plus 1 leaves us with 4x plus 5. Technically, at this point, you can already see your answer, but we want a legit no variable setup. So if we take away the 4x's, those are both 0. Now you have 5 equals 5. What is that? That's always true, right? That's the identity, because your variable is no more. So that's always true, which is an identity. Okay? Questions on that? Next one.
They're going to specify whether to solve to see if it's in a solution or identity problem versus solving to find the variable.
Not necessarily. If your variable goes away, then you'll know this is identity or no solution. If your variable sticks around, then you know it's x equals fill in the blank. Okay? All right, 2x plus 3 times x minus 4 equals 2, parentheses 2x minus 6 plus x. So to simplify this one, we got to do the distributive property, right? So we're going to distribute here, and we're going to distribute here. We get 2x plus 3x minus 12, because that negative 4, or that minus 4. Then 2 times 2x, so 4x, minus 12 plus x. Okay, now combine your like terms. 2x plus 3x is 5x minus 12. 4x plus x is 5x minus 12. Again, you can see it right now. They're identical, right? Identical means identity. But technically, you would take away the 5x and get negative 12 equals negative 12, which is an identity. ¿Está bien? All right, last ones. And these are always the ones that drive people a little more nutty. But here's what I need you to think, okay? You know how to solve, like those ones that I just did, right? You know how to solve those. These are no different, except that now there's more letters, but it's the exact same steps, okay? So this is literal equations. You're gonna solve something in terms of some variable, but there's gonna be other variables there too, okay? You're just trying to isolate one variable. So, for instance, if I say K equals C plus 273, and I say solve for C. Okay, that means I want to get C by itself. How do I get C by itself right now?
Subtract 273 from one side.
You subtract. So 273 from this side, 273 from this side. K minus 273 is not simplifiable, right? So you leave it as K minus 273. This is 0, this is C, you're done. Okay, I think it frustrates people because you want C equals a number, and it's not going to be a number, and that's okay. So don't get frustrated when you have a lot of stuff left at the end. That's totally fine, okay? How about this one? A equals 1/2 BH. Tell me what that's for, geometry students.
Pyramid.
Triangle. That's triangle. 1/2 base times height. Okay, so here's the deal. We want to isolate H. What should I do first?
Subtract 1/2.
Multiply by the reciprocal, or in this case, you can just multiply by the whole number because the reciprocal is the whole number. So if I multiply by 2, that's gone. And whatever I do to one side, I have to do to the other, right? So I end up with 2a equals b h. I want to solve for h. What do I do? Divide by b. So this is gone. My answer is 2a over b equals h. Okay, as soon as you get that variable isolated, you're done. Don't try to solve it with numbers. There's no numbers to work with. Just leave it at that. Okay, how about this one? X over m plus 5 equals y. We are going to solve for x. What should you do first? Remember, this is kind of reverse PEMDAS, right? You're going to subtract the 5 first. Just imagine you have numbers everywhere, right? So you have x over m equals, because this goes away, y minus 5. We want to solve for x. What do we do? Multiply by m. So here's where you have to be a little bit careful. I multiply by m here. When I multiply by m on this side, I can't just stick the m in front of the y. I have to use what? Parentheses. Okay? So it's going to be, this is gone, x equals m times y minus 5.
You can't put NY. It's 5.
You could, yeah, if you wanted to distribute it, that's not wrong. You don't need to, but you could. Can what? You could put it at the back, yeah.
Well, I just wrote it that way.
Okay, last one. How are you feeling about this? Is this okay? I feel like Algebra 1 freaks out about this, and you guys, you've matured. Yes.
Very slightly.
I never taught any of you in Algebra 1, did I?
Nah. I was taught by Eric Schulte.
All right, we're going to solve this one for x. What do you do?
I would say do the 3 first and then
Which 3?
multiply by 3.
You're going to multiply, right. So we're going to get that division bar out of there by multiplying by 3. So I'm going to multiply by 3 on this side, and I'm going to multiply by 3 on this side. So this is going to reduce to 1. We get x minus 3 equals 3 times a plus b in parentheses, and we're solving for x. What do we do? We're going to add 3. So you get x equals 3 times a plus b plus 3. And who said it? Sam?
Yeah.
Or was that Bo? You can distribute that and do x equals 3a plus 3b plus 3. That's fine too, but you don't need to. As soon as you isolate the x, you may be done. Okay? So this can be your answer. Questions? Comments? Concerns? We good? Hopefully we still feel like we're reviewing. Yes?